Hello, so this time we will continue with Chapter 6, Geological and Geophysical Investigation. Basically, there is difference between these two field of investigations. So for geology, geology investigation, geologists will study directly, compared to geophysics. So their study is indirectly. So for geologists, they will analyze outcrop, discontinuity or fall, for example. So before that, what is the meaning of outcrop? So basically, outcrop is a visible exposure of a bedrock. So let's say they have an area, and then they will study what is type of discontinuity that present on that area. For example, is it available fault, bedding or foliation, and then aperture, and then so they will measure the deep direction, deep angle. If you still remember in lab 4, the raw material from table 1. So basically that data is represent the raw data for this continuity for a site. And then second, they also can analyze the rock. They can bring that sample, for example core sample, they can bring in labs, before this maybe analyze on site, and then they also can further analyze in lab, to better understand what is the chemical composition, for example the available in a rock, or what is the physical characteristic. So if you still remember in lab 3, so you can conduct point load test, to determine the indirect strength, for a rock sample. And then for geophysics investigation, so this study is indirectly. So therefore, normally for geophysics, they will use a method, for example, as seismic, seismic imaging, electromagnetic methods, or gravity methods, or any other various methods. So basically, this is to build a mapping or a picture, and then this is to represent what is the condition underground. Because for example maybe the condition underground involve a certain deep, a certain depth, in subsurface. So that's why the suitable method is will be so the suitable method will be used by geophysics to determine the condition of subsurface or underground. So the geological investigation or geophysics, basically it can be classified as site investigations. So what is the purpose of site investigation? So basically, this testing, this is to determine a condition or characteristic underground, and then this data will be used to design, for example, foundation, for foundation, to design, for example, foundation, retaining wall, or soil improvement, and so on. So in this article, so basically, for example, a geophysics method, have been used, for site investigation for a building foundations. This picture shows the Leaning Tower of Pisa. So this is example of failure, due to a lack of site investigation informations. Because this tower was constructed in 1173, and then during that time there is lack of geologists or geological knowledge, and then there is also lack of available equipment, for conduct the site investigations. So this tower begin to lean or tilting, soon after the constructions. So what happened is, at softer area, maybe this is softer area, Okay, so this strata has settled more, okay, and then it caused the tilting of this tower. Okay, so this is the example, okay, due to the lack of site investigations. Okay, site investigation can be divided into two. So the first is Macintosh probe test, or the second is Borlock sampling. Okay, basically for Macintosh probe test, this is for small project, and then basically this test is carried out to determine the bearing capacity, which is to determine the strength of soil. Okay, then if you want to get a detail, okay, for characteristic underground, so then the Borlock sampling can be used. So for Borlock, normally it will use the machines, the drilling machines, to get the earth sampling. It's depend on the certain depth required. Okay, so for site investigation, so a few tasks involved, for site investigations. Okay, so planning, the first one is planning, there's study, and then investigation, okay, drilling. So that's why in this chapter is focused on bore log. Okay, so that's why for bore log, it will involve the drilling explorations, and then the last task is observation into borehole. Wash boring is a common method, in site investigation that have been used around the world. So the purpose of wash boring is to obtain the sample or sampling. Okay, and then the wash boring is a fast and simple method, and then it does not require a complicated equipment. Okay, so for example, for soil sample, it can be taken by using a split barrel, and then for rock sample, it can be obtained by using core barrel. Okay, this picture shows the process in wash boring. So as you can see, the equipment is simple to use. Okay, so it use water flow, to soften at this area, and then this is the a barrel or casing, a casing that contain the barrel, to take the soil sample or rock sample, and then this is the cutting tool, in order to drill, deep into the a certain depth of soil. Okay, and then finally the sample can be taken, from this barrel. So this is the difference between split barrel and core barrel. So for soil sample, because the soil sample is soft, so then this barrel are required, to be split, so that the soil sample can be easily taken out. Okay, compare to rock sample, because this is in a solid and intact rock, so then the barrel does not require to be split, so because they can easily uh, carry out the sample, the rock sample, without splitting the barrel. So this is the difference between split barrel and core barrel. Okay, for rock sampling, typically it requires two dimension. For example, for granite rock, so the dimension of core is about 6 meter. Meanwhile, for limestone, so limestone is sedimentary rock, it requires 12 meter. And then this sample, all this rock sample, need some interpretation, need some calculation. For example, in terms of RQD, TCR, and SCR. So RQD is referred to Rock Quality Designation Index. So TCR is Total Core Recovery. SCR is Solid Core Recovery. Meanwhile, for the physical test, because this sample will bring to the lab, and then it will test for the strength test, for example, unaxial compression test, tri-axial compression test, point load test, and Smith hammer test. Okay, RQD is to check the quality of rock sample. So the definition of RQD is the percentage of intact core pieces, okay, that have length more than 100 millimeter, okay, in the total length of core. And then the diameter of core should be at least 54.7 millimeter. So the next slide is about the calculation of RQD. Okay, how to calculate RQD? Okay, because RQD is based on the length of core pieces that are more than 100 millimeter or 10 centimeter length over the total length of core. Okay, for example, this is your core sample. Okay, you get from your barrel, okay, during drilling. So you just check the pieces that have length more than 10 cm. Okay, it's depend. If you use cm, so it's depend on the given data. So if the centimeter, so you use 10 cm. So if the dimension is millimeter, so it needs more than 100 millimeter. Okay, so okay, you just check. For example, this is the pieces number 1. So the length is 38. So this is more than 10 cm. Okay, this is less than 10 cm. Okay, 20 more than 10 cm. Okay, then based on the RQD calculation, so you can classify, for example, very poor, poor, moderate, good, and very good. Okay, depend on the percentage of RQD. So beside RQD, you also need to calculate the TCR, okay, total core recovery, and SCR. So for total core, okay, means that core recovered, okay, over length of core. So for SCR is solid core in full diameter. So we will see later what is the TCR and SCR. So this is an example how we want to calculate RQD, TCR, and SCR. Okay, for RQD, okay, because the RQD is for the core that have length more than 100 mm, or if the unit in cm more than 10 cm. Okay, right now the given dimension is meter. So for the RQD, the length of core must more than 0.1 mm. So you just take, okay, this is your total core, okay, or total length, okay, your core sample. So you just take pieces that have more than, that have length more than 0.1 mm. So for example, so the pieces number 1, 0.23, and then 0.33, so 0.24, because this one is less than 0.1, and then 0.15. So over the total core, okay, the total core is 0.5. So you will get the rock quality is about 63%. Okay, it's quite simple, kan? And then, okay, then we go to total core recovery. Okay, for total core recovery is, okay, I will show you after this. Okay, meanwhile, for solid core recovery that have a full diameter. Okay, for example, in this example, it takes as 0.18, 0.71, 0.17. Okay, maybe basically this sample, this example is not really clear, but I will show you in another example, okay, to get more clear about this calculation. Okay, how to get total core recovery? Okay, for example, let's say this is your sample, your coring sample. Okay, for this is sample 1, and for example this is sample 2. Okay, maybe due to the vibration, okay, some of your sample will be in the broken pieces. So for measurement of total core recovery, you need to push the broken pieces together so that you can develop a full core volume or a full set of core. Then you measure the length of this full set pieces. So this one you call as total length of core recovery. So we have finished about geology investigation. Now we go to the geophysics investigation. So for geophysics, this method is actually non-destructive, okay, because they use some device to check about the underground. Then the selection of geophysics method depend on the parameters to be checked. Okay, for example, the shear modulus, Young modulus, and so on. So in engineering geology, geophysics is used to determine the boundary of conditions, to locate bodies of unusual properties such as voids, buried pipes, and so on, or to determine the engineering properties of materials and mass. So the choice of method will depend on the particular circumstance of work and also the environment. So the example of geophysics method such as ground penetrating radar, resistivity, seismic refraction, seismic reflection, and gravity. And then for seismic, it can be borehole or based on the surface, okay, meaning that the equipment was put on the surface. And then the measurement can be either refraction, reflection, or surface wave. So basically, it needs a point source, and then it needs receiver. And then this is the difference between reflected and refracted wave. Okay, as you can see, this reflects, okay, from the source point, okay, at on the surface, so it will reflect to the receiver. Okay, compare to the refracted wave, so it will go through on a layer, and then at the end, after a certain length, so it will refract again to the receiver. Okay, this is GPR. So this is the equipment of GPR that normally used on site. So it's portable. Okay, for example, during site investigation, so suddenly they have some culvert. So this culvert will reflect, okay, the wave. So that's why the image will be like this, or in your screen it will appear like this. So this image will show that there is something below the ground. Resistivity is based on electrical method, so it can be used to measure conductivity and resistivity of the ground. So conductivity means it allows the flow of electrical current. Meanwhile, for resistivity, meaning that it's electrical resistant, it resists the electrical current. Okay, this is the equipment of the electrical resistivity. So for basic resistivity tests, it require, okay, normally it require minimum 4 electrode. So the first electrode is for current, and then the other electrode is for potential receiver. Okay, electrode receiver, current and Table 7.3 shows the resistivity and conductivity value for rock sample. Okay, for example, take one example of rock, granite. So from this value, it shows that granite has high resistivity, or high electrical resistance compared to electrical flow. Okay, high resistivity compared to conductivity. Okay, normally it will inverse between each other. If a sample or a material have high resistivity, meaning that it will shows low conductivity. Okay, for example, if marine water, it shows high conductivity, so the resistivity is low compared to conductivity. And then when compare granite and sandstone, for example, so granite shows high resistivity compared to sandstone, okay, due to granite is more dense compared to sandstone. Okay, so this is for a revision. So resistivity is a properties of a material to resist the flow of electricity. So when conductivity, a property of a material to conduct the flow of electricity or the allowable of low electricity. This is called conductivity. Okay, for seismic refractions is due to the seismic wave that refract from a surface to another surface, and then this refraction will be picked up by geophones. So that's why in the previous slide, it must have some source and also it must have some receiver. So this is the equipment for seismic refraction. Okay, seismic refraction was measured by travel time of refracted wave. So this refracted wave was created by give an impact or shock at a point. For this example, this is a point as a source point, and then this impact or shock will create wave that can travel along the layer. So different density of this material or layer or rock will give different velocity and different wave speed. For seismic refraction, normally the wave was travel along or pass through material. However, for seismic reflection, the wave was reflect from the source to the receiver. Okay, normally this seismic reflection was ideal for mapping geological at a certain depth, more deeper compared to refraction. So that's why this seismic reflection was not really suitable for shallow exploration. This technology also is quite expensive, and then that's why normally this seismic reflection normally very rare or not conducted in small scale.